The next is moment couple. Suppose here we apply two external forces which has opposite direction but same magnitude, and they are separated by the distance of d. So of course, each of these force will create moment about point O. We can write the moment about point O, which is caused by the positive F, which has the distance of A plus T. Then it is minus by F times A. So now the moment about point O will be F times T, which means it is independent with the position with respect to point O. So the magnitude will be determined only from the force magnitude and the distance between them. So this is the moment couple. In the term of vector operation, we can doing like this. For external force of F, it has point of application at A, and minus F has point of application at B. A and B has the vector position of RA and RB with respect to point O. And the position, the relative position of point A to the point B is represented by vector position of R. So then we can write in the vector operation that the moment created by this force F is the cross product of the vector position RA with F. And for the second force, we can also do the same thing, cross product of RB and minus F. So we can see here that the moment couple as a vector can be obtained as the difference between the position of point A and B, or the relative position between F, the couple of force, times the force itself. So now let's make things clear by summarizing this discussion, that if we apply a couple of force which has same magnitude but opposite direction, and both of them is separated by the distance of d, then we can calculate the moment which is created by the couple of force, or simply we can call moment couple, as F times T. And this magnitude can be applied at any point. So it doesn't change if we move the rotational point at point O or at O axis, because the position is not influence the moment couple. Okay, so consequently, the moment couple can be created in many ways. So for example, instead of using this couple of force, we can create another couple of force here. Which can give the similar effect or equivalent condition with the previous one, as long as F and the distance times the distance still the same. Okay, so next about moment couple is the direction. So the direction of moment follow the rotation which is created by couple of force. So for example here, couple of force will create a rotation in the counterclockwise direction. So we call this counterclockwise couple. And in opposite, we have here clockwise couple. Now let's see several different conditions of each blocks. Here we have 4 blocks with different couple of force at different location, at different point of application. But all of them have the equivalent condition, have the equivalent effect. All of them have the couple moment of F times D. Disregard of the location, the force given. So for the first block, we apply the couple at the top surface. We can obtain the similar effect, the similar condition. Here we can still obtain the couple moment Fd if even if we change the point of application at the bottom surface. Or even if we change the direction of F, the location of F, still have the similar effect, same condition. And sometimes we can modify the force with the distance, okay? As long as the product of the multiplication between F and the distance still follow this magnitude, then all of them are in the same condition. We can make use that on the analysis. So here we have force couple system. Means that we will have force and moment couple on the rigid body. So now let's see if we apply an external force at point A on the rigid body, and we have point B as a reference, as the axis of rotation, for example. This is the reference. Then if we apply a couple of force here at point B, which has same magnitude but opposite in direction, so they virtually cancel each other. So this is just like adding a zero force at point B. So the effect will be the same with the previous one. There is no force acting at point B. So this is the equivalent condition. But as we know that this couple of force can produce moment couple, so it will turn or rotate this body like this with a moment of F times D. Because we already reduced this couple of force into this moment couple, then we have another force at point B. So to summarize this, we can modify or we can change the point of application of force on the body to the other point. But we have to add additional moment couple as the consequence of moving this force. So here we already moved the force from point A to point B, but because it has additional moment couple, so we put here the moment couple, and the rotation is following the direction of this couple. Okay, so we can interchange this condition. So we can bring this single force and represent it with the force and couple. So we call this force couple system, or vice versa. So we can simplify a single force with single moment couple into another single force only, but it already changed the location. Okay. This will be useful, very useful in the force analysis. When the force in a practical condition is very complicated. We will be able to simplify them using this concept. So now let's see the example here. We have a crank here, link, which is at point O, and we apply the external force at the other end. So we will have to move this force from this point to point O and give additional moment because we change the point of application, so that it is expected that we can draw the force at this point and moment. But why we move this analysis from the top end to the bottom end? Of course, because we are interested in the load that work on this support. Suppose this is bearing. So this bearing must resist this load and receive this moment. Okay. So knowing this F and moment can allow us to, can guide us to choose the appropriate bearing for the structure. So let's now solve them. Here we add a pair of force, which is equal in magnitude with this one, but they have opposite direction, so cancel each other. So virtually this is 0. Then next, we see this pair of force, this couple, as a moment couple. So then it is simplified with this rotational or moment. Now, in the same structure, we only have moment couple and a single force at point O. Now we are already able to move the external force from the top end to point O and add the moment couple there. So to understand this concept more, please do the exercise.